Hello everyone. In this video we are going to solve AMC 8 2020 full exam. So let's start. Let's solve problem 1. Luca is making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar and twice as much sugar as lemon juice. He uses 3 cups of lemon juice. How many cups of water does he need? So in order to solve problem, we can set up ratios. So it says 4 times as much water as sugar is needed. So we can say water to sugar is 4 to 1 and twice as much sugar as lemon juice. So sugar to lemon is 2 to 1. In order to write all as one ratio, so we can set it up like this, and then we will multiply the first by 2. So we will then write 4.2 dot 1, or we can write it like 8 1. And now we have to answer that he uses 3 cups of lemon juice. How many cups of water does he need? So since he is using 3 cups of lemon juice, so we can simply multiply all of these numbers with 3, and we will get then 24, 6 and 3. So then the answer that we have is 24, and that is E. Problem 2 states 4 friends do yard work for their neighbors over the weekend, earning this much amount respectively. They decide to split their earnings equally among themselves. In total, how much money will the friend who earned $40 give to the others? So to solve this problem, all we have to do is just take the average of their earnings and then subtract the average from the $40, so which was earned by one of their friends. So what we can do is first we calculate the average or mean. So we say average is equal to, and now if I take the difference, so that would be then 40 minus 25, and it is 15. So the answer is C. Let's look at problem 3, where Carrie has a rectangular garden that measures 6 feet by 8 feet. She plants the entire garden with strawberry plants. Carrie is able to plant 4 strawberry plants per square foot, and she harvests an average of 10 strawberries per plant. How many strawberries can she expect to harvest? So first we will see that what's the total area for this rectangular garden. So that is 6 by 8 feet, and he is able to plant 4 strawberry plants per square foot. So we then will have we can set it up like this, like strawberries harvest equal to total area multiplied by plants per square foot, and then multiply by strawberries per plant. And now if you see, the total area is 48, and we have 4 plants per square foot, and then there are 10 plants. So if we multiply, we will get then 48 multiplied by 40, and if we solve this we will then get 19, 20. So the answer is D for this problem. So let's solve problem 4, where we are given 3 hexagons of these shapes, and it says suppose the pattern continues so that each successive hexagon contains one more band of dots. How many dots are in the next hexagon? So if we see in the first hexagon we have one dot. In the second one we have 3 layers, and the first layer has 2 dots, the next has 3, and the next one then has 2 dots. So I'm talking about these dots. In the next layer, in the third one, the first one has 3, then 4, 5, 4, and 3. 3, 4, 5, 4, and 3. So if we take the next hexagon, that would be hexagon 4, so then it would be 4, 5, 6, 7, and then we will have 6, 5, and 4. And the total number of dots will be simply 4 plus 5 plus 6. And similarly, if we add, so we will then get 9, 15, 22, 28, and then 37. So the answer should be then B for this problem. Okay, let's look at problem 5, where 3/4 of a pitcher is filled with pineapple juice. The pitcher is emptied by pouring an equal amount of juice into each of 5 cups. What percent of the total capacity of the pitcher did each cup receive? So we are going to find percent cup received. So that would be equal to 3/4 of pitcher divided by 5 cups and then multiply by 100. So we can just simplify it. And now if we solve, we will then get 15%. So the answer is then C for this problem. So let's look at problem 6, where Aaron, Darren, Karine, Marine, and Sharon rode on a small train that has 5 cars that seat one person each. Marine sat in the last car, Aaron sat directly behind Sharon, and then there is another condition and another condition, and we have to answer who sat in the middle car. So to solve this problem, we can make a block diagram and then assign each person to one of the blocks. So let's say that each block represents a seat, and this is the back, and this is the front. So we can say Marine is sitting in the last car, then Aaron sat directly behind Sharon. So it means that Aaron and Sharon, they will be in this position. Now another condition is Darren sat in front of the cars. So if Darren is sitting in front of Aaron, so it means that Aaron and Sharon, they should be either here or they should be here, and then Darren can go in this spot or in this spot. So however, it says that at least one person sat between Karine and Darren. So then what we can do, in this problem, then we have to set now Darren here. That would ensure that she is in front of Aaron, and then we can say Aaron and Shireen here, and then Karim is here. So if we set it up like this, then the answer for this question, it becomes A. So Aaron is the one who is in the middle card. Let's solve problem 7, where it says how many integers between 2020 and 2400 have 4 distinct digits arranged in increasing order. And an example is given here. So to solve this problem, we can see that we are given the range between 2020 and 2400. So there are a couple of observations that we need to make. The first digit, it must stay as it is. We cannot change it, since the first digit in the other or in the higher range is also the same. The second, it should be 3 in order to fulfill this condition in the increasing order, and it cannot be 4, because then we will be out of this range that is given. So now we have to find out that how many combinations are possible for the last two numbers, so, or the last 2 digits. So we have 2 here already, and this number is 3. So it means that this number that will be coming in this place, that can be 4, 5, 6, 7, 8, or 9. And as per this condition, like, they are 4 distinct digits and in the increasing order. That means that the last digit, it should be different than the digits that will come or will take the place for the third digit. So how we can set it up? Then we can say that since these digits are 6 and we are having now 2 places, so let's say that this is our third place, this is fourth place. So for the third place, we have 6 options, and for the fourth place, then we will have 5 options, because the digits cannot repeat. And we also need to ensure that the digits are in the increasing order, so that's why we will then divide it by 2, and then the answer that we will get, that will be 15 for this problem. So the C is the answer for this question. So let's look at problem 8, where Ricardo has 20 coins, some of which are pennies and the rest of which are nickels. He has at least 1 penny and at least 1 nickel. What is the difference in cents between the greatest possible and least possible amounts of penny that Ricardo can have? So the total coins that we have, they are 20, and some of which are pennies and others are nickels. Okay, so we can set it up like this, like greatest amount and minus the least amount that is possible. So if we see the greatest amount that is possible, that is simply 2019 multiplied by 5 plus 1 multiplied by 1 and minus 2019 multiplied by 1 plus 5 multiplied by 1. So just to explain, here these are the maximum nickels and they will maximize the price or the amount, and here is 1 penny only, and again to have the least amount then there should be 2019 pennies and 1 nickel. So now we can solve this problem just by rearranging. And now if we solve this, so we will get then 8076 minus 4. So then it is 8072 should be the answer. So it is C. Let's solve problem 9, where a birthday cake in the form of 4 by 4 by inch cube is given and shown here. The cake has icing on the top and the 4 side faces and no icing on the bottom. Suppose the cake is cut into 64 smaller cubes, each measuring 1 by 1 by 1 inch, as shown here. How many small pieces will have icing on exactly 2 sides? So this is the most important thing that we need to keep in mind, that we have to tell exactly 2 sides. So this problem is simple. What we can do, we can simply count the number of cubes, but we need to make sure like they should have icing on the 2 sides only. So if I see 1, 2, 3, and similarly then I will have 1, 2, 3. They will have these 6 cubes, and similarly I can have 1, 2, 3, and 3 then will be on the last edge or the hidden edge that is not being showed here. That's in the into the plane of this iPad. So anyway, so from here I can then have 6 and 6, 12, plus I will have 1, 2, 3, 4. So I will have then 4 more cubes, and I will also have this and these, so 4 from here. So the total cubes that I will have with 2 faces having icing, they are 20 in total. So the answer is D for this problem. So let's look at problem 10 that states Zara has a collection of 4 marbles and a guy, a bumblebee, a stelly, and a tiger. She wants to display them in a row on a shelf but doesn't want to put the stelly and the tiger next to one another. In how many ways can she do this? There are multiple ways to solve this problem. One of the more or simpler way is just to simply apply the George Harry theorem. So as per that theorem, we can find the number of ways that we can arrange A distinct objects when B objects are away from each other. So the theorem, it is named as GEOR, George Harry theorem, and so the number of ways is equal to A minus B factorial, A minus B plus 1 factorial divided by A minus 2B plus 1 factorial. So here A, it represents the distinct objects. So we have 4 marbles, so there are 4 distinct objects. And B is basically how many objects are not next to each other. So then I can simply apply it to 4 minus 2 factorial, 4 minus 2 plus 1 factorial, divided by 4 minus 2 dot 2 plus 1 factorial. So if we solve, we get then 2 factorial, we get then 3 factorial, and divide by 1 factorial. And then the answer, it becomes 2 multiplied by 1 multiplied by 3 multiplied by 2 multiplied by 1, and that is then 12. So 12 is the answer for this question. Let's solve problem 11. That states, after school, Maya and Naomi headed to the beach 6 miles away. Maya decided to bike while Naomi took bus. The graph that is given here shows their journeys, and we have to find out what was the difference in miles per hour between Naomi's and Maya's average speeds. So we have to calculate their average speeds. So as we know, the formula for calculating the speed is simply distance over time. So the distance that was covered by Maya, so that was 6 miles. So I will just label it as SM for distance that was covered, or the speed Maya, that is for Maya. So D is the distance, and that is in miles, so it is 6 miles. Divide by the time, and the time that we have, that is 30 minutes. So I will just convert this 30 into the hour. So then if I simplify, I will get, sorry, it should be 30. So if I solve it, I will get 12 miles per hour. So similarly, we can calculate for Naomi. So Sn, that would be then equal to the distance, that is again 6, and the time that it took, that is 10 minutes, and then we can solve it, and we will get the speed, that is 36 miles per hour. And now in order to tell the difference between their speeds, we can simply subtract both speeds, and the answer then that I get, that is 24 miles per hour. So E is the answer for this problem. Move to problem 12. So where we are given a positive integer n, the factorial notation represents the product of the integers from n to 1, and an example is given here. What value of n satisfy the following equation? So this is what we have to answer. So let's solve it. We are given five factorial dot 9 factorial equal to 12 dot n factorial. So what we can do in this problem, we can expand 5 so to make it equal to 12. So let's do that. So now from here I can see that this 4 multiplied by 3 and 12, they are equal, so I can divide both sides by 12. So I can write it then 5 multiplied by 2 multiplied by 9 factorial multiplied by 12 divided by 12, and here I can do again the same thing, divide by 12. And now if I see it cancels out, and n factorial is equal to 10 multiplied by 9 factorial, and that is equal to 10 factorial. So which gives us that n is equal to 10. From here the answer is A for this problem. So let's look at problem 13, where it says Jamal has a drawer containing 6 green socks, 18 purple socks, and 12 orange socks. After adding more purple socks, he noticed that there is now a 60% chance that a sock randomly selected from the drawer is purple. How many purple socks did Jamal add? So we can set it up like this. So let's take the ratios of the purple socks with the total socks. So the purple socks that we have 18 plus P, which are the newly added purple socks, and then the total socks that we have, they are 36 plus P, and that ratio is equal to 60 over 100. So then if we simplify, we can write it like 3 over 5. And now we can simply cross multiply and solve it. So then here is 108 plus 3b, 90 plus 5. And then we can collect the terms on like on one side of the equation. So we get then 2p equal to 18 and p will be equal to 9. So the answer is then B for this problem. Guys, let's solve problem 14 now, where we are given this bar graph, and that is about population of 20 cities, and we are also given cities here on the x-axis. So it says the average population of all the cities is indicated by the horizontal dashed line. So this dashed line, it represents the average. Which of the following is closest to the total population of all 20 cities? So what we can do, we can simply take the average and multiply by 20. That's all that we have to do in this problem. The other option could be like to take the quantity for or the population for each city and then add that up, but that's very time consuming. So let's do it in the faster way. So now if I read, I can see that each of this grid, that is 500. So, and it is 2000 here. I have 4000 up there. And then this is 4500. And this dotted line is in the center of these, like this 4500, and it is between 5000. So then it would be 4750. So to estimate the population, I can simply multiply for the total population. I can multiply 4750 with 20. And if I multiply, I get 94 and then 95. So it should be then 95,000. So the answer is then D for this problem. So let's solve problem 15, where it says suppose 15% of x equals 20% of y. What percentage of x is y? So what we are given is 15% of x equals 20% of y. So 15% of x equal to 20% of y. And we have to tell what percentage of x is y. So basically we have to rearrange this equation for and isolate y. So let's first simplify it. So I will get 3 over 20 multiplied by x. So here I will get then 1 over 5 y. So if I multiply equation on both sides with 5, then I can isolate x. So I multiply by 5 on both sides, it cancels out, and y is equal to now 15 over 20x. Or I can also write it like this: y is equal to 3 over 4x. Since the question is asking in terms of percentage, so I will now convert this 3 over 4x into percentage by multiplying with 100 and 25. So I will have then 75x. So then the answer is 75%. So it should be C, the answer for this problem. Okay, so now let's look at problem 16, where we are given this diagram, and it mentioned that each of the points A, B, C, D, E, and F in the figure below represents a different digit from 1 to 6. Each of the 5 lines shown passes through some of these points. The digits along each line are added to produce 5 sums, one for each line. The total of the 5 sum is 47. What is the digit represented by B? So first we can represent the sums in terms of the alphabets which are given. So if I make all of them, I get A plus B plus C. Then I can get another, that is C plus D plus E. And then similarly I can get another line, that is A plus F plus E. Similarly I will get another line, that is B plus D. And I can get another line, that is B plus F. So now I will sum them up and I get 2A plus 3B plus 2C plus 2D plus 2E's and plus 2F, and that is equal to 47. And now if I see other than B's, the rest are all alphabets, like they are appearing twice in this sum. So I can rearrange this equation like this. 2a plus 2b plus 2c plus 2d plus 2f plus b. So I just brought this b outside here, and now I can write this sum as 2 into a plus b plus c plus d plus e plus f plus b equal to 47. So we are already told that the numbers are in the range of 1 to 6, right? And they are different for all the cases. So it doesn't matter what number we assign, but if I take sum of numbers from 1 to 6, that is, so if I add, I get 21. So 21 is the sum of all of these alphabets, but at this stage we don't know what is the value for any of these alphabets. However, what we know, the sum. So the sum is 21, and I can put that here. And now I have one unknown, and I can solve for that. And that unknown is b. So b is 5 then. And the answer is E. Problem 17. So where we are asked to find out factors of 2020 that have more than 3 factors. And an example is given here. So first we need to find the prime factors for 2020. So the prime factor that we have, we can find them with this method. We just write 2020 and divide it with 2. We will get this, then we divide with 2 again, we get 505, and then with 5, and then we get 101, and then if we divide with 101, I get 1. Since 101 is the prime number, I cannot do anything further. So now the prime factors that I get, they are okay. So now I need to see how many total factors are possible. So total factors, I can simply calculate by taking the power of each prime factor and add 1 there, as I'm doing here. So now if I multiply these, then I will get 12. So the 12 are the total factors that are possible for this number. So now I will write all those 12 factors, and from them I will find out which factors are having factors more than 3. So if I list down the factors for 2020, the first one is definitely 1, second is 2, 4, then I have 10, 20, 101, 202, 404. Similarly, I will have 505, 1010, and 2020. So let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I think I missed one of that. 1, 2, 4. I think 40 should be 1, 2, 4. Oh, sorry, I missed 5. Okay, 5 was one of the factors. So now the total factors that I have 12 factors. Now I have to check how many of these factors they have more than 3. So I can solve it in the opposite way as well. Like if I first see how many have 3 or less. So I would write number with factors less than 3. So for example, if I look at 1, so we know 1 only has one factor, so I will write then 1 as one factor. 2 can have two factors, one is 2 and the other one is 1, so 2 will have two factors. 4 will have three factors, 1, 2 and 4, so it will have three factors. Then 5 have 1 and 5 two factors. And similarly, if I see 101 also has two factors, so there are two factors for 101. So other than that, if we check all of the number, they will have factors greater than 3. So what we will do now, we can simply subtract 5 from 12 and then the answer will be 7. So 12 minus 5, that is equal to 7. This 5, it is coming from these numbers 1, 2, 3, 4, 5. So if you sum that up, it's 5. So 7 are then the factors of 2020 that have more than 3 factors. If you want to check, you can check. For example, if you want to check 10, so you can see that 10 has 1, 2, 5, 10. Similarly, if you check others, they have more than 3 factors. I hope it explains. Okay, so let's solve problem 18, where we are given this shape and we have to find the area of this rectangle that is inscribed in this semicircle. So some of the dimensions that we are given, they are the length of DA, so that is 16, and we are given FD equal to AE equal to 9. So we are basically given the dimensions for this and for this segment as well. And we have to tell what is the area of ABCD. So to find the area of ABCD, we need to know the length for DA, and also we need to know the length of DC or AB. So we are given DA, that is 16. However, we have to find DC. So we can find DC by making use some of the dimensions that we are given here. So if we see, we are given the total diameter of this segment, and the diameter is 16 plus 9 plus 9. So that would be 25 and then 34. And if I calculate the radius, that would become 17. And that is this. So if the radius is 17, so that means that if I create a triangle, so then this value is 17. And since this is the midpoint, so then I will have 8 from D to this point. Let's call this point O. And then we can find the length of CD. So we can apply basically the Pythagoras theorem. So with that, DC equal to 17 square minus 8 square and the square root of that. So then we would simply get 289 minus 64, and that is 225, that is equal to 15. And this length, if I write a, it is 15. So now I can plug this length here and I can solve it for the area, and if I multiply I get then 240, and that is the answer for this question. Let's problem 19. That states a number is called flippy if its digits alternate between two distinct digits. For example, 2020 and 37373 are flippy, but 3883 and this one are not. Okay, so we have to find how many 5-digit flippy numbers are divisible by 15. So to solve this problem, first what we can do is make 5 spaces, one for each number, and now we can make a couple of observations based on the divisibility rules, that a number to be divisible by 15, it has to be divisible by 3 and 5. So if we recall, for a number to be divisible by 3, then the sum of all the digits should be divisible by 3, and for 5, if a number is divisible, then it should end in 0 or 5. So if I write zeros, then I can, if I write for example 0 here, so then this number will not be the possibilities, because this is basically a 4-digit number, it is not a 5-digit number. So this is not the option. So it means that we will only be having the number ending with 5. So then I can write 5, 5 and 5. So now I need to see what number I can fit in these two spaces. So if I write 0 and I sum these number up, it is 15, so that is divisible by 5. So it means that one of the answer is this. Second, I can try 1. That would not work, because if I add them up I get 17, so that is not possible. So similarly, like if I add now a number with having 2's here, that will also not work, because it is 4. 6 will work, 3 will work, because if I add I get 21, so this would be my second number. So similarly, I can now add the multiple of 3's, so I can then add 5 6 5 6 5, that would be the third number, and another number would be 4. So the answer for this question is then 4, that is B. Solve problem 20, where a scientist walking through a forest recorded as integers the heights of 5 trees standing in a row. He observed that each tree was either twice as tall or half as tall as the one to its right. Unfortunately, some of her data was lost when rain fell on her notebook. Her notes as shown below, with blanks indicating the missing numbers. Based on her observations, the scientist was able to reconstruct the lost data. What was the average height of the trees? So a couple of things that we need to keep in mind. The recordings were all integers that she did. So based on that, if the number 2 tree is 11, then the 1 it should be 22, and 3 is also then 22. So now we can have multiple possibilities for tree 4. One of the possibility for tree 4 is 44, or it can be 11. Based on the possibilities that we have for tree 4, the result then 45 will be based on that. So now let's make the list. So what our numbers are, and then we will take their sum and take the average. So let's say we have 22 plus 11 plus 22 plus 44 plus 22. And similarly, we have 22 plus 11 plus 22. And similarly, we will have the third possibilities, that is 22 plus 11, 88 plus 44. So one of the main observations that we can make from these numbers is in order for a number to end in 0.2, then the sum of the digits, it should be the sum of the numbers, it should be equal to 1 greater than the number divisible by 5. So all what we need to see, then the number, it should either end in 1 or it should end in 6. So let's see which number it ends in 1 or 6. So if we add the first one, we get 55 plus 44 plus 22, so we get 66 plus 55, so we get basically 121. And if you divide it with 5, you will get, your answer will end in 0.2. And then if we further solve it, we'll get 24.2. So then the answer for this problem is B. Let's solve problem 21, where a game board consists of 64 squares that alternate in color between black and white. The figure below shows square P in the bottom row and square Q in the top row. A marker is placed at P. Step consists of moving the marker onto one of the adjoining white squares in the row above. How many 7-step paths are there from P to Q? So to solve this problem, we have to keep in mind a couple of things. First is that the path, it should consist of 7 steps. And another thing is that all the paths, they should be taken on, or the steps on the white adjoining squares or the adjacent squares. So if we make a couple of observations, the first is the maximum that we can go towards the left is this limit. So we can go up to this path, and then we can go directly from here to above. We cannot go beyond that. And on the right, we already have a limit due to the edge, so we can only go up to this, and then we can take the other path. So now we have to find the number of ways. So if we see, when we move from P to this box, we can have only one way of going, and similarly we have only one way of going from here to here. So similarly, if I move to the next square, I have only one way, and if I move to this square, I have one way. However, if I move to this middle square, I can have one way coming from here, and the other way is from this side, so I can have 2 ways to go there. So similarly, if I move to this square, so I can then have one way, and plus 2 are coming here, so I have then 3 total ways. And similarly, like if I check for this square, I will also have then 2 and plus 1, 3 ways. So if we see, there is a pattern that is emerging, that is that the above row, it has the number of ways based on the number of ways which are on the bottom row. So for example, this 2, in other words, it's a sum of the number of ways that I have here. So similarly, like if I apply this pattern, so I will have 6 for this square, and for this one I will have only 3, and for this square I will have 1 and then 3. So that will give, sorry, that would be 4 now. 3 plus 1, 4, and then I get 10 and I get 9, and this one will be 9 again, and this becomes 19, and this q then it has 28. So the answer is then A for this problem. So let's solve problem 22. When a positive n is fed into a machine, the output is a number calculated according to the rule shown below. If n is even, then the output is n over 2. If n is odd, the output is 3n plus 1. So for an example, if 7 is input, then the output is 22. Okay, that makes sense. And if 34 is the input, then the output is 17. So that is basically divided by 2. And we have to answer that when the 6 step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers? So when the final output is 1, we have to find the sum of all integers for n. So to solve this problem, we can set this problem in the reverse order. So we have our function as output equal to input over 2. So we can set it up like input equal to 2 multiplied by output. So let's say that this is one option we have. The other option that we have, that is our output equal to 3 input plus 1, or we can write it in the reverse order as input equal to output minus 1 over 3. So now we apply these two functions in the reverse order to see what like options we get and which one are legitimate. So we start with 1. The 1 is the last value or the final answer. So if I apply both to 1, I will get 2 or I get 0. So now if I apply in the next step, again the both functions, I get 4, and I also get 1 over 3. And if I apply this 0, so I get 0 and I get negative 1 over 3. So from here, if I see this is not possible, this is also not possible, and also this is not possible, it will just keep repeating it. So now let's go move with 4. So if I apply in the next of 4, so I get 8, and the second that I get is 4 minus 1 over 3, and 3 over 3 I get 1. So in the next step, now if I apply again, I get 16, and then I get 7 over 3, and for 1 I have 2, and I have 0. So this is, yes, 0. So this is again not possible, so I will keep these two. And now if I apply again this 16, I get 32, and I get 5. For number 2, I get 4, and I get 1/3. So 1/3 is not the possibility. So now let's move to the sixth step. So I get 64. And the second possibility that I get is 32 minus, that is 31/3. From here I get 10, and also I get 4/3. From 4 I get 8, and also I get 3, 1. So now if I see, this is not possible, this is not possible. The possible ends are then 64, 10, 8, and 1. So if I sum these up, 64 plus 10 plus 8 plus 1, the answer is then 83. So E is the answer for this question. Let's solve problem 23, where 5 different awards are to be given to 3 students. Each student will receive at least 1 award. In how many different ways can the awards be distributed? So we have 5 awards which are to be distributed to 3 students. And it says each student will receive at least 1 award. So based on this condition, we can define our 2 test cases. So one of the test cases, there are 3 awards which 1 student will receive, and then the remaining 2 students will get 1 award each. The other test case is there are 2 students who will receive 2 awards each, and 1 student will get 1 award. So now let's find the number of ways for each of this test case. So since at the beginning 3 awards are available to all 3 students, so that is 3 choose 1, and since there are total 5 awards and choosing 3, so now 2 awards are left and 2 students are left. So it means then now there are only 2 ways that the awards can be distributed to them. So then we add the next, or look at the next test case. So here we have now one of the student is getting 1 award. So basically then 3 choose 1, it can be any of these 3 students, and now has available 1 award from 5. So that is 5 choose 1. And next is you can have now the remaining 2 students, so they can have 2 awards each. So the remaining awards after choosing 1 are 4. So it is 4 choose 2, and then 2 choose 2. Let's solve for the total number of ways. So let's solve this first, and that is 3 multiplied by 5 factorial over 3 factorial into 2 factorial and multiply by 2. So if I simplify, I get 60 for this, like half, and similarly if we solve this we will get 90. So the total answer, or the is then. Let's solve problem 24, where a large square region is paved with n square gray square tiles, each measuring s inches on a side. A border d inches wide surrounds each tile. The figure below shows the case for n equal to 3. When n is equal to 24, the 576 tiles cover 64% of the area of the larger square region. What is the ratio d by s for this larger value of n? So, what we have to find out, as stated, we have to find out d over s. D is the distance between the tiles and the edge, and also between the tiles. So this is actually d we have, and also we have d we can see along the vertical sides as well. Okay, and s is the side length. So from here we can make one observation. If n is 3, then the distance along each side is 4. So the number of distances. And if I just write it here, n equal to 3, and then the number of distances is 4. So now if I express the side length for the square in terms of s, I can write it as 3s plus 4d. And similarly, I can also express the side length in this side as well, 3s plus 4d. Now I can extend the same idea when n is equal to 24. If I extend that to 24, then the side length for a larger square would become 24s plus 25d. So in order to find the ratio d over s, I can express everything in terms of the ratios of the areas, because I am given that 576 gray tiles cover 64% of the area. So since it is a square and side length is this, so I can then write area for the 576 tiles divided by the total area of the square. And that is equal to 64 over 100. And now if I take square root on both sides, I get 24s over 24s plus 25d, 8 over 10. And now if I do the cross multiplication, I get then 24s, 240s equal to 192s plus 200d. And now if I rearrange, I'll get then 48s equal to 200d, and then d over s is 48 over 200. And if I further simplify this ratio, then I get 6 over 25. So the answer is then A for this problem. Okay, so now let's look at the last problem, 25, where the rectangles R1 and R2 and squares S1, S2, and S3 are shown here, and they combine to form a rectangle that is 3322 units wide and 2020 units high. What is the side length of S2 in units? So we have been told the width is 22 wide and the height is 2020. So from here, if we make an observation that the sum of the sides like S1 plus S2 and plus S3 is equal to 3322. So S1 plus S2 plus S3 is equal to 3322. And similarly, I can also write S1 minus S2, that is this, and then plus S3, that is equal to 2020. So I can write S1 minus S2 plus S3, that is equal to 2020. And now I can solve these equations like the substitution method or the elimination. So I will just use the substitution method, and if I simply subtract these equations from each other, it cancels out, this cancels out, and I will be left here is 2, 0, 3, 1, and 2s2. And if I divide both sides by 2, I can get 651. So that is the answer.